Welcome back to our website of Tech Talks. We are still empowering you more with the education skills. And today we are going to look at more examples on factor formula. More examples on applicability of factor formula. In the previous video, we are looking at how to solve equations where we could apply factor formula. Now today we want to look at a scenario of proving the identities. You can start with example 1. I can say show that sin theta minus 2 sin 2 theta plus sin 3 theta all over sin theta plus 2 sin 2 theta plus sin 3 theta equals negative tan squared theta by 2. So we want to show that the left hand side equal to right hand side. And we say that when there is a word show, strictly start from the left hand side, then you go to the right hand side. But if it is talking about proof, you can either start from any side which you are easy to derive what we want. So we can look at our solution. We are considering the left hand side. What we do, last time we said that when you are solving, you bring those ones with bigger angle and the one with a smaller angle. So I'm going to bring this and this one close. So we go on, this becomes sin 3 theta plus sin theta minus 2 sin 2 theta all over sin 3 theta plus sin theta plus 2 sin 2 theta equals, here we are going to apply factor formula, again factor formula. Again recall that sin A plus sin B, when we are dealing with sin plus sin, we are coming out with 2 sin of A plus B by 2 cos A minus B by 2. You remember what we did there. Now when we go to sin 3 theta, sin of 3 theta plus sin of theta is the same as what? This is like A, this is our B. So we're going to have 2 sin 3 theta plus theta by 2. Then we say cos of 3 theta minus theta by 2. So we go ahead, this becomes 2 sin 3 theta plus a theta, we get a 4 theta. Then divide by 2, we are coming out with 2 sin 2 theta cos 3 theta minus a theta, we are coming out with the 2 theta. Again divided by 2, we are going to come out with theta. Now, where we see these scenarios, these events, we are going to put in these ones. So we say sin 3 theta plus sin theta minus 2 sin 2 theta all over sin 3 theta plus sin theta plus 2 sin 2 theta is the same as the whole of this one. We have already come out with 2 sin 2 theta cos theta minus 2 sin 2 theta all over the same, because it is a plus down, we say 2 sin 2 theta cos theta plus 2 sin 2 theta. Now go ahead, observe, apply mathematical theories. What is common here and there? I'm seeing there is sine 2 theta, sine 2 theta. Again, there is 2 sine 2 theta, 2 sine 2 theta. So I pull out that one. We use what we call, we factor out what is common. So we are going to say 2 sine 2 theta into, what I've remained with? I've remained with a cos theta minus 1 all over, what is again common here is 2 sine 2 theta into, I've remained with cos theta plus 1. So this one and this one crosses. We are going to remain with cos theta minus 1 all over cos theta plus 1. Our interest is create a tan squared. You can see it is in terms of half angles. So we also recall from the double angle formula from the multiple angles, or what we call, now we are dealing with the half angles. So can say cos 2 theta, when you had cos 2 theta in terms of a sine, was the same as what? Was the same as 1 minus 2 sine squared theta. Now, if you can see the angle is double, what if I have now cos theta is the same as what? 1 minus 2 sine squared theta by 2. I think we are getting that. Or you can get use of the T formula. Also, when you had cos 2 theta in terms of cos was given as what? 2 cos squared theta minus 1, which we derived in the previous videos. Now, when I have now cos theta is the same as what? In terms, you can see when it is double, it is bringing a single. Now, when the angle is 1, it's going to be half of it. So it's going to be 2 cos squared theta by 2 minus 1. So, can we substitute in these expressions here? We are substituting in cos theta minus 1 out of cos theta plus 1 is the same as what? So when you see this one, I'm going to bring the one in terms of a sine. It's going to be 1 minus 2 sine squared theta by 2 minus 1 all over. Where I see a cos, I'm going to bring this one. I say 2 cos squared theta by 2 minus 1. Then again there is a plus 1. So we try to arrange. 1 and 1 disappears. I'm going to remain with negative 2 sine squared theta by 2 all over. Negative 1 and 1 disappears. We remain with the 2 cos squared theta by 2. What happens with the 2 and the 2? It disappears. I remain with negative sine squared theta by 2 all over cos squared theta by 2. Now, what do we know about sine over cos? Sine over cos, we automatically come out with a negative tan squared theta by 2 as required. So conclude, therefore, what was given was sine theta minus 2 sine 2 theta plus sine 3 theta all over sine theta plus 2 sine 2 theta plus sine 3 theta is giving us negative a tan squared theta by 2 as required. That's how we do such kind of a number using the idea of the factor formula.